In math, people often invent ways to extend concepts to areas that might not make sense at first. Pretty much everyone can understand what 2 to the third power means because they understand that it represents multiplying by the number 2 3 times. Yet what does 2 to the 0 power or 2 to the negative 4 power mean? Does it make sense to talk about multiplying by a number the negative amount of times? So let's look at this. We've done some of this already, so some of this may seem familiar. So 2 to the 4th power is 2 times 2 times 2 times 2. 2 to the 3rd power, 2 times 2 times 2. Remember, you can always do this times 1 also. 2 to the 2nd power is 1 times 2 times 2 equals 4. 2 to the 1st power is 1 times 2, which is 2. 2 to the 0 power is what? Well, let's go up above. And let's see what these became at the end. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 1 times 2 is 2. 2 times 2 is 4. 1 times 2 is 2. So for 2 to the 0, I just have 1. There's not a 2 that I'm going to put there, so the answer is 1. So that means something, which we'll get to later. So positive exponents indicate multiplying the number 1 by 2 repeatedly. Then negative exponents should indicate division. And that is a D. So 2 to the negative 1 power is 1 over 2 to the 1st power. 2 to the negative 2 power is 1 over 2 times 2, which equals 1 over 2 squared, which equals 1 over 4. 2 to the negative 3rd power is 1 over 2 times 2 times 2, which is 1 over 2 to the 3rd power, which is 1 over 8. And finally, 2 to the negative 4th power is 1 over 2 times 2 times 2 times 2, which is 1 over 2 to the 4th, which is 1 over 16. We want the pattern of positive integer powers to extend to 0 exponents and negative integer exponents. We can now define 0 and negative exponents as follows. 0 exponents is anything to the 0 power equals 1. And negative exponents, when it's to the negative power, it just becomes a fraction, and it is then a positive exponent in the denominator. So which of the following is not equivalent to 5 over negative 2? Well, 5 over negative 2, that's 1 over 5 times 5. Well, 5 times 5 is 25, so this one works, so that can't be the one that's not. Well, 1 over 5 squared also works, so that's the one that can't be. And there's no way that 3 and 2 are the same, so 1/10 has to be the answer. And then 1 over 25, if you were to divide 1 divided by 25, you get 0.04, so there's no way that 4 is also. So if f of x equals 3x to the negative 2 plus 2x to the 0, then which of the following is the value of f to the 2nd power, or f2? So 3 times 2 to the negative 2 plus 2 times 2 to the 0 power. Well, automatically, this becomes 1. We know that. But then it becomes 3 times 1 over 2 squared. And this is adding. So it's adding 2. Well, 1 over 2 squared becomes 1 over 4. 3 times 1 over 4 is 3/4. Well, 3/4 plus 2 has to be the first one, 2 3/4. Because we now have negative exponents, we can develop a third exponent law. Recall that we already have the following two. We know that when we multiply exponents with the same base, you just add the exponents. We know that when we have power of a power, you multiply the exponents. So now let's see if we can develop a rule for dividing quantities that have the same base. Well, I have x squared over x squared, and it's going to be multiplied by x to the third over 1. Remember how in the last lesson you make one of them equal to 1? So this one's equal to 1. So x to the third power is your answer. So now I have 3 to the 5th over 3 to the 5th, and I'm left with 3 to the 5th over 1. So this is gone. So 3 to the 5th is your answer. And our last one, x squared over x squared. So I'm left with x to the 6th over 1. So that is 1. So x to the 6th is your answer. So what's happening each time? Well, x to the 5th over x to the 2nd becomes x to the 3rd. And 3 to the 10th over 3 to the 5th becomes 3 to the 5th. And x to the 8th over x squared becomes x to the 6th. So what's happening is you are taking A and subtracting B. You are just doing a subtraction problem every time. You do not need to make a multiplication problem like we did up above in A, B, and C. You can just simply subtract. Now that we have a pattern that works quite well, let's look at what happens when the denominator is bigger. Well, first of all, 2 to the 4th over 2 to the 4th becomes 2 to the 4th minus 4, which is 2 to the 0, which is 1. Obviously, if the numerator is the same as the denominator, then it will always be 1. The next one, I kind of skimmed this in the last section, the last lesson, that you look where x is larger. Well, this one, x is larger on the bottom, and then we subtract. 7 minus 2 is 5. When you have nothing left in the numerator, you just put a 1. Well, 5 is larger in the bottom. You subtract, so it's 4. Put 1 in the numerator. So now we see that the subtraction rule for exponents is consistent with negative and 0 exponents. For now, we just want to be comfortable that negative exponents indicate division and positive exponents indicate multiplication. So let's look at this. Letter A, if we're going to put 0 in for that x, then I have 16 times 2 to the 0 power, so 16 times 1, so 16 is my answer. What if I have 16 times 2 squared? Well, now I have 16 times 4, so 64 is my answer. And the last one, 16 times 2 to the negative 2, so 16 times 1 over 2 squared, so 16 times 1/4. So it becomes, whoops, not 16, it becomes 4, because what you're really doing is 16 times 1/4, or 16 divided by 4 is 4.